Welcome back. We are COMP1116. That's Game Programming 3 in the fall 2025 semester at Georgia, and it's week 1, part 3 of our broadcast and recording. And in the last part, we were struggling, some of us, to put things in, to connect our project to DevOps, but now, for the most part, most of us have connected, and we've pushed everything to DevOps. Let's check to see if you have everything up there. And the way to do that, of course, is go back to DevOps and refresh. And you should see this or something like it, okay? If you see this or something like it, that's a good sign that you've pushed your repository to DevOps. If you don't see this or you see an empty repository still, something is wrong. You've pushed to the wrong place. That can happen, okay? So don't panic. You can always do these steps again. All right, so now that we've done this, let's add to our code. Our code is very primitive. All we've done here is spent some time connecting to DevOps because that's part of our everyday in-class exercise, and that's why I spent so much time doing that. But now what we want to do is we want to modify this. Okay, who can tell me some of the principles of object-oriented programming? So OOP 101, name a principle, any principle. No one. Bueller? Anybody? No? Object-oriented programming, what is it? It's a design pattern, or design flow, right? And we use our programming language, and we're using our programming language to structure our program so that we have objects and classes. That's what we have, right? So remember that classes, going back, this is just review, are containers. They're a blueprint for objects. That's what they are. Back in Unity, you created some classes, for example, the player behavior class or something like it. You know, maybe you called it something else, player controller. And the player behavior or player controller, what it did was it brought your object to life. It gave your object some, performance, whatever it is, whether it moved around, whether it shot a bullet, whether it got destroyed. All that stuff was done within that C# code, and it used a class, and that class usually inherited from monobehavior. And monobehavior, of course, inherits from some other class, and so on, as it goes on. So it's a big chain of inheritance. So one of the principles that we can say of object-oriented programming is inheritance. We know that it inherits from other things. Strength of object-oriented programming, right? Another feature of object-oriented programming is information hiding, right? We want to encapsulate our data members away from the rest of the world, right? We want to have private instance members and public properties. Now, in C# and in Unity specifically, you didn't do that because everything is public, or otherwise it wouldn't show up in the inspector unless you modified it. As an example, you serialized the field, and then you could see it in the inspector. If you didn't do that, you wouldn't be able to see it, so you have to make it public a lot of times. But here, when we're learning C++ for the first time, we want to create a class, and the class is going to have two sections, a private section and a public section. It could have up to 3, actually. Let's do that now. Let's make our first class in C++. So I'm going to do it in the same file here for today. And I want to use the class keyword. That's important. And the class that I'm going to call this class the person class. And my person class is going to have these features right now. It's going to have the class, the keyword class, the name of the person class is person, right? And we're going to have curly braces followed by a semicolon. That is the default minimum requirement for a class in C++. Okay? It looks pretty empty, and it is, right? And where this is different than C# is, remember that C++ is a lot leaner, right? It's modular. What we want to do is add stuff to, to C++. I'm going to do this is a classic example that I'm giving you right now, and I'm just going to hide some of this so we can see more real estate here. So I want to have two sections. I want to have a public section, and I want a private section. In C++, you can describe sections inside of your class by using the keyword public or private with a semicolon, the colon at the end. Okay? So in this area here, that's all your public stuff. And in this area, that's all your private stuff. What do these things mean, these access modifiers? What's public, what's private, what does that mean? Yes?
Private is like only what's contained in script, if I remember, and public's accessible from anywhere.
Okay, that's good. Remember that in C#, and when we're using Unity, that's a script. Here, we're a programming language, right? So in our programming language, you're right, the public keyword is give access to anything inside that section is going to be accessible to any other class outside of this class. Private means it's only accessible inside the class itself. What about this other keyword, which kind of is in between these two things? What's the other keyword that we're missing? Protected. So there's also the protected keyword. Public, protected, and private. What do you think the protected keyword does if it's in this, if it's in that accessible order? Yes? It can be accessed by this class as well as its child classes. So if a class inherits from this class, it also has access to this stuff that's in the protected section, right? But if I only put it in the private section, only this class has access to it, nothing else. Okay? So 3 levels of access: public, protected, and private. Those are the 3 levels of access. Okay? One thing we know that we have in any class is a constructor. What is a constructor? Who knows what it is? A constructor is a function in C++ or a method in C#, right? And the constructor triggers whenever I instantiate an object of that class. I know I use a bunch of the words here, right? I use the word instantiate. It means I'm breathing life like a magician into this new object. It becomes alive, right? That's what instantiate does. I allocate memory for this object, and I create it based on the blueprint, which is my class. That is instantiation, okay? In C#, I use the new keyword to do that, right? In C++, we don't need to use the new keyword right now, okay? But we do need a constructor. The constructor function is the first function that automatically triggers when we do something. I also have a couple things here. I'm going to define some private data members, okay? I'm just using comments here. And my private data members, right, I want to have 2 things, 2 data members. One of them is going to be a name, and the other one is going to be age. A person probably has a name and an age. Again, a classic example, okay? So for my age, that's no problem. I can put int, and I can probably put age, right? I can probably do that. Int is an integer, age, right? You're not gonna, I mean, I could make it a float too if I want to make you like 1.5 years old, 20.7 years. I could do that, but today I'm just going to make it an integer. You're 5, you're 7, you're 10, you're 20, you're 30, you're 50, okay? So that's the first thing. And this is good, and this is the data type, int, right, data type, and this is the identifier, or we also call this the variable name for the variable, right? But identifier is the formal way of calling it. The identifier name, or the identifier, is age, and this is non-descriptive for us. Age, it looks like any variable age. We can make it better. If it's private, many people, what they do is they use m underscore in front of it, like this. So it looks uglier when you look at it, m underscore age. But m underscore means member variable that's private. The underscore means private. Member variable means part of the class, right? A private member variable, that's called age, right? And it's a very common construct when you see m underscore everywhere, okay?
If you were to say instead of n, those other letters, would those
You could. No result. That's not the result. It's just our coding style. It's our coding style. So we're defining a coding style. So when you see me do m underscore in the future, you know it means member variable that's private. Okay. Next, we want to add string. We want to do a string, right? And we want to call it m underscore name. But there's a problem. String does not compute. Why? String is a complex data type. It's not like integer or float or byte or character. It's a complex data type, which means we need a library for C++, right? So at the top, we're going to include another library called string. That's not enough though, because string is part of the standard template library, the standard library. We're going to use std in front of it with a delimiter, like so. That is the way we do it in C++. In C#, you just have to put string. C# takes care of everything. C++, everything is under your control. Yes? Delimiter, think about the standard in std as the namespace. The containers are all classes inside the standard namespace. Colon is like, find this. Inside means inside of the namespace, find this. So it's almost like a dot accessor. Find is like, you know, it's an accessor, basically what it is. Like colon or delimiter is an accessor, right? It allows you to access the class inside of the namespace. Okay? Okay, so now that we have standards, you know, colon, string, m, name, we have our data members, but the problem is we don't do anything with them. These are all private, and what I want is a constructor function to initialize these data members for the first time. So let's make the constructor. Remember the rules of constructors in C# and in any other language. You must use the name of the class. So in our case, it's person. There are a couple of constructors. One of them is the empty constructor. This is the empty constructor. This is what this is called. Empty constructor. Also called the default constructor. Okay, that's what it's called. Empty or default constructor. The empty or default constructor is sometimes we use this because we want to instantiate an object without initialization. We don't want to initialize our anything inside. We don't want it to do anything. We can initialize after, or you know, again, it's problem solving, right? But we don't want to do this. We want, instead of an empty or default constructor, we want a parameterized constructor. Let's do that instead. Parameterized. Parameter. There we go. Typo? Sure, I'm sure I did it. What does this suggest? There we go. Parameterized with an E. So the parameterized constructor has parameters. It has stuff that it takes in, right? Inputs. So one of them is going to be name. And I want to say that I want to use the standard string that is going to be name this time, and an integer, which is going to be age. That's what I want. And then inside of my constructor, I want to initialize. All right? This is called initialization. That's what this is doing. Okay? So I want to initialize my data members. I get input from my constructor function, and it happens when I'm instantiating an object of type person, and I've taken the input and I'm assigning the input to my private data members. That's what's happening. Going from a public constructor function to a private data member. Remember that you do not have access to these two private data members outside of this, this class. Now, I'm getting some of these curly, you know, kind of warnings. And what they're telling me is, and again, I'm using ReSharper. And this is a great tool for you guys to use. This is not AI, okay? So if you go to ReSharper, and if you go to ReSharper for Visual Studio, JetBrains is a great tools company. They make things like Android Studio and a bunch of other things. You can sign up as, you know, as a student and get an educational account with JetBrains. They have a great number of tools. One of them is also something called CLion. It's an alternate to Visual Studio for C++. Okay. However, one of the things that you want is you want, if I go to features or plugins, maybe it's on tools. Here, tools. Here we go, tools. They have something called ReSharper, right? And ReSharper C++. ReSharper C++ is part of the .ultimate package, right? And it's not free. It's proprietary. You have to pay for it. But because you're students, you can use this as long as you're a student. You can install this ReSharper and use it in Visual Studio, and it's not cheating. I will completely accept this. I highly recommend it. Why? It's going to save you typing. It does something else. It doesn't do replacement. It does code completion. All right? That's different than AI, all right, where it does the code for you. This kind of completes the code. You start typing, and then it tries to figure out what you're doing, and also, whoop, it gives you the rest of that code. Where it's really great is Unreal Engine, where we have a million lines of code and lots of code completion we can do. And instead of you trying to remember all that, it'll do it for you, right? 100% way to go, okay? And very valid. Okay, so now this is good. This is ReSharper C++. Highly recommend. I have it installed in Visual Studio. Unfortunately, for the machines in front of you, if you're using the machine here in the lab, it's not available. Why? It's student specific. And no matter how I try with IT, they would not allow me to install, even though it's a student thing. You have to have a license. We don't have a license, and it's an IT headache, so it's not installed in the machines in front of you. Okay? But if you have your own machine at home, which you should have if you're doing hybrid weeks, 100% recommend. Okay? Now, what it's telling me is, if I hover over, it's basically saying that the name is copied for each invocation. And what this means is that I'm actually allocating more memory. Every single time I instantiate an object of type person, I'm making a copy of my string literal instead of using the memory that's already been allocated. So what they recommend is something that's really cool. There's a little light bulb that comes on here, and you can basically say, I want to pass the parameter by reference. So two things happen here. I get the const keyword. The const keyword makes a constant instead of a variable. A constant parameter cannot be changed inside the body of the function, right? This creates a safe variable that comes into the function. You cannot change it no matter how much you want to do it, right? Then we get the ampersand. This ampersand next to the string, what this means is I want to pass this value by reference as opposed to making a copy. Passing by reference points to the memory location and takes that value in memory and passes it along. The memory location doesn't create a new copy for you, which is less overhead. And especially for game dev, you want to keep your overhead super low because it reduces frames, right? So you want your high frame rate, low overhead, which means more passing by reference and less copy, right? That's what you want to do. We can do the same thing for age, but instead of passing by reference, because we can't, string we can because it's a complex data type. We're actually passing a class, the string class, an object, right? But int is a primitive type, so all we can do here is make it const. Okay, that's what we can do, make it const. And now this is a more type-safe example of a parameterized constructor we can use for the person class, okay? Anyone confused about the words I'm using? I'm going to try and keep using those words over and over again until you get used to them. Yes?
I'm not quite confused. I just need you to go over the definition of const again, because I'm trying to find notes.
Const makes sure const makes a input like this in new.
Okay.
It makes it unchanging, right?
Okay.
As opposed to a variable that is new that you can change. Okay?
So like it's a constant variable.
Constant, yes, a constant data member, if you will. All right, so that's what it does. So it kind of takes in this constant thing. So inside of this scope means from in this curly brace area, that's the scope of the function, right? In that scope, that name, lowercase, and age, lowercase, the input parameters are constant. You cannot change them inside that scope. And they only live and die inside that scope. Outside of the scope of this function, age and name, those lowercase parameters do not exist. Okay? Back to this. So now that we've instantiated an object of type person, that's what we do here, we want to get some kind of output. And we can do that, again, inside a public function. This time we'll return void, and we'll call a function says hello. And what we're going to do with this function is we're going to do another cout. So we're going to say standard cout. And this time we're going to say m_name, and then we're going to say says hello. Okay. Remember standard cout, we're going to output to the standard console, and notice that there's two little arrows this time, two sets of arrows, right? The first set of arrows is going to output the string name that we're getting from the constructor function. So example, in this case, if it's Tom Tom is going to be saved inside of my member variable called name, right? And then here is where I'm outputting just Tom, right? Then I add a space between Tom and says hello in this function, and that is the second stream that I'm sending to the console. So there's one stream here, and there's a second stream here. Then there's a third stream here, and this third stream is different. It's a standard end line. This standard end line is equivalent to, we can erase it actually, and we can make it just like we did before, \n. So standard end line, standard ENDL, is the exact same thing as this, \n. Okay? Both are interchangeable. In fact, I can even use both together. I can use many \n's. I can do this too. I want to do 3 lines, right? Right? Or I can use the same thing over here. I can say something like standard end line, right? I can do both. I can do 2 lines, right? But all we need is 1. All right, this, my friends, is the person class, right? I want to test it by instantiating an object of type person and configuring it. How do I do this? Now that I have the person class, are you with me? Have you finished the person class with me? Yes? Yes? Anyone not finished? All right, let's instantiate it. Back down to the bottom, we can wipe this out. We don't need this, this is just beginning, right? And let's make it. So we'll say, hey, I want to make a person object. I want to call it Tom, and I want to make it so that it is this. Notice that name and age are phantomly appearing there. That's not me typing it. That's ReSharper telling me that those are the label names. Don't put those in there. All you need is Tom and 30, or whatever your name is and your age. By the way, I'm not 30. It'd be nice, but that's what you can do. And this is instantiation. So what this does is this instantiates an object of class person, right? And then what we can do is we can use the Tom says hello. We don't need the return 0. That's implied. So Tom says hello, what this is it calls the say hello method, well, this is actually a function, right, on the object, which is very accurate, actually. This is what it does. So the dot accessor, notice that I'm using, you asked a question about a delimiter. See the dot, that is like another type of delimiter, another accessor. It's giving the method or function says hello inside the Tom class, or inside the person class, in the Tom object. Okay? Now, I want you to use your name for this. Don't use Tom. Okay? So I know I can identify you. If I see Tom, you'll get 0. This is you, not me. And it's your practice, too.
Is there anyone in this class who has the same name as someone else?
You can use your own name. If you want to do your full name, you can use your full name. Don't worry about it. I'm not going to be so harsh. I'm saying just don't use Tom. I don't think anyone's called Tom, right? Don't worry. Okay, so now that I've got this, let's test it. If we did everything correctly, I should be able to press play, right? And I should be able to get Tom says hello. Let's see if that works. So it compiles here. It compiles, builds, and runs. And now we get Tom says hello. You should see your name, whatever your name is, says hello. Are you with me?
Yes.
Okay. If there's someone who's not with me, figure out what happened. What happened, right? What'd you do, right? So this is an example of the person class. Let's push this through to DevOps now. Okay, here is the protocol to push to DevOps. First, we can do it right in here, inside of the developer PowerShell, okay? We can bring this up. If you don't have this, you can go to View Terminal, okay? That's also something you can do. And if you can't use it, like some people can't use it, you can just use the separate terminal window like I talked about before. But here, what you can do is this. Here's the first command, git add dot. Git add, git is the program, add is the verb, the action. I want to add something. Dot means everything. I want to add everything to the staging area. That's what I want to do, right? The staging area is a place that I've checked off. I've checked off all the files that I want to get a snapshot of for my commit. The commit is a snapshot of your files and the current state that they are. That's what a commit is, okay? So that's the first line of code. Next, now that I've added everything to the staging area, the next thing I need to do is add a commit. So git commit minus m for message, that's lowercase m, and then a friendly message like added the person class. Something that's relevant, something that's appropriate, okay? The message to what we added, a feature, something we fixed, whatever it is, that's what we use. Those are the two commands so far, git add, git commit, and the last one is git push. Let's push it. So git add, git commit, and git push. Yes, that's a finger. I should think about it. Add dot git commit minus m, and in quotations message, and git push is the next command. If you push, it's going to push everything to DevOps, like so, okay? And that is what you should see right here, like this. I'm going to just make it bigger so you can see it. This is all what you should see right here, okay? Git add, git commit, git push. Git add, git commit, git push. This is your workflow, your Git workflow, which is exactly what we do with Gap. If you had a GitHub desktop, it's exactly what you're going to do. You're adding something, or you're checking out some files, and then you're pushing to GitHub, right? Now we're just doing it manually. Add, git commit, git push. All right. Now that we've done this, let's check DevOps. Let's check DevOps. So if I go back to DevOps, and if I refresh, you're going to see a new commit here that's going to pop up. Take a look. It says added the person class, right? And who did it? Me. I did it. You can look at the history as well, right? This is a history of all of your commits for this project, right? Visual Studio did 2 of them. It added git ignore and git attributes files and project files, as well as what we did. Okay, so those are the 3 commits we have right now. Notice I have a little picture of myself in my name, right? That little picture is a gravatar that comes from your GitHub repository, or you can actually sign up for your own gravatar if you really want, okay? So if you go to gravatar, I believe gravatar.com, right? You can sign up for your own gravatar. You can create it yourself, okay? So it's a way of doing it so that your picture is always around. You can use that gravatar everywhere. Okay? Back to this. So now that I have, this stuff, it's ready to go. That's my second commit, really. First commit was what we did with Visual Studio. Second commit was this. Let's continue to modify it. All right, so that was me to do. Now I want you to do. This is for you to do, okay? I want you to help me with this one, okay? So here's my person class. I want to add another class, and this time I want to make it the student class. How do I do it? What do I do? And how do I make the student class inherit from that person class? How do I do that? Here's some stuff. I'll start it with you together. Let's do it for the first time, okay? So we're going to go here. We're going to say class student. That's the name of the class. And then colon public person. Now, if you've never done this before, and most of you have not, you're going to be like, wait, what's going on here? Okay? Notice that my student class is outside of my person class. They're not inside each other. They're separate. Okay? Next week, what we're going to do is we're going to have separate files for everything. A file for my student class, a file for my person class, a file that's .h, a file that's .cpp. We're going to separate everything, right? Which is the right way to do it. Today, we're learning how to walk. Next week, we're learning how to teleport. That's where we're going to go. That's how fast it's going to go, guys. So there is no flying. It's like walk to teleport, because we have to do a lot. Yes?
So instead of, it would just be this one script would be the person class, and then we make a separate script.
We have 2 scripts in the person class, a .h and a .cpp. And then we have 2 scripts for 2 CPP, and a third and another fourth file for our main. Right?
Okay.
For what? Or fifth file for main. All right, so let's do this now. So this is the person class. So this means that, hey, student, I want you to inherit from, that's what this means, or extend. This means the student class extends the person class. That's what this means. So this is the student class, right? And if we have to use the extends keyword, that's what it is, the person class, right? Extends, this extends word is actually this colon right here. In other languages, we actually use the extends keyword. For example, in TypeScript or JavaScript, we use extends. In other languages, we use extends. Some languages, we just use colon, right? But there almost every language you program in, whether it's Swift, Kotlin, C++, C#, Python, it's some form of extension or inheritance that we're doing here, okay? So that's what we're doing here, extends the public person. Now, someone in the morning asked me, why public? How come we just can't say, how come we just can't do this, right? And we can't. But here's the question for you guys. What is the default access modifier for classes in C#? What is it? Private. So too is it for C++. It's private, default, right? So we're explicitly telling C++ that I want to use a public version of the person class to inherit from. Yeah, man, right? And you're going to say, well, that doesn't make sense. We should always do that. You're right. Most of the time we do. However, remember that C++ and other languages, general programming languages, use these constructs to solve problems. At some point in time, it was required for us to have control of what type of class we're inheriting from, right? And that's why this construct exists in this programming language. Otherwise, it wouldn't exist here, okay? So there's a reason for it. We don't need it, but it's there for our control. Next, now that we have that, we should, starting off, I would do a public section, right? A protected section, and a private section. Those are the three sections I would instantly create all the time. Okay, those three things. Public, private, protected. And this way, you can decide what goes where. I want a constructor function for the student class. What do I need to do? Help me out here. We just did one with person. Let's see if you can figure out how to do the one with student. Yes?
Inside the public section,
Yes?
the student with whatever
Parameters? Okay. So question, what parameters do I need for a student? You don't even know. What new data member do I want for a student? Let's add student ID, right? So here's student ID. I want to make it that it's a standard string. We'll call this m_student ID, right? M for member variable, underscore for private, okay? So I want definitely the student ID to be initialized, right, inside of my student class. But what happens with my other parameters? What about all these? I mean, look, we have to, the student class must, when it's instantiating, must take care of the constructor function that's here. We must take care of this. And the reason why I'm saying it like this, must, is because there is no default constructor. There is no empty constructor. So because there's no default constructor, we have to send a parameterized version back to the superclass. By the way, superclass, parent class, base class are all the same. Derived class, child class, right? Subclass, they're all the same. Okay? Just different names for the same things, different languages. Okay? So what this means is because we have to take this information in, we need these parameters as well. We need all of this. Okay? So that's the first thing. We take all these ones. Right? And we also need a parameter for student ID now because now we're also initializing a student ID. So here, we're going to say that standard, let's do the same thing, const standard string ampersand, which means pass by reference, student ID. But let's make an underscore for this, student ID. Sometimes for parameters it's done a little bit differently than it is for things. Student ID underscore is a little bit easier than this. Now notice it has an underline. It says base person is not initialized in this constructor. It actually tells you that there's an error, right? And the reason why is because we're not taking care of this thing. We're not doing this. All we're doing is, we haven't done that yet. So how do we do that? You can simply add a colon inside of your, just before the curly braces, right? Or we can say that we want to do name and age, like so. That takes care of the constructor. How? We take the name and age that's incoming inside of my student constructor, and we pass it forward to the person constructor. That's what we're doing. This right here is actually the call the super constructor. Right, I'm calling it super because a lot of times we'll see super in Unreal Engine. Super means pass it to the parent class. Okay, who doesn't get this and who's confused? Why may you do this? You're kind of like, I don't know why. Think about it, right? I construct an object in my person and it needs two things. It needs name and age. And now I'm making my student is a subclass or inherits from my person. I need to initialize name and age. And I'm not doing that unless I pass it back towards, up the line towards my person class, which is I'm inheriting from. And that's what this is doing. I still have to initialize my student like this as well. That's also required, right? Otherwise, I haven't initialized all my member variables, if that makes sense. So this is your student class. Now, I want to create another function, a public function, and I'm going to have some trouble, okay? Here's my public function. I want to make a function that is called studies. Students study, right? I want to make this student study. What is my problem if I want to output the name of the student that is studying? What is my problem going to be? Let's try this, and I'll show you the problem so you can see it. I make a new function, void, it's not returning anything, called studies, right? And inside my function, I want to do a standard cout, and I want to pass my m underscore name that's going to say something like is studying, right? Like it says here. It's nicely giving me the answer. But it's an error. It's a problem. Why is this a problem? Why is it an underline? If you hover over, it'll tell you why. It says the member is inaccessible. Why is it inaccessible? Why would m underscore name be inaccessible? I mean, remember, we just inherited from the person class. Why is it inaccessible? Yes?
Would it be because that's a private part of it?
Absolutely. Because name is private, it's only available in the class itself. If we want to make name and age available to my child classes, we need to make them protected. So we can do a couple of things to make it easy to do that. We can wipe out the private name here inside of my person class, and now we can just make these protected, right? Protected means now that they're available here in my student class, and I'm good to go. Now, warning, protected is a wider kind of level of access. When we want to have security, especially with certain things, we want to limit our access. Widening our access is a security hole, right? So we want to limit the times we do this, only when absolutely necessary. There's other things we could do here instead of doing this. For example, we can create something called getters and setters. Who knows what they are? Yes.
Get is receiving information, setting, exchanging information.
Or get accessor, set mutator. That's the way you want to think about them. The get accessors and the set mutators. In C#, there's an easy way to do that. Get, set. It's actually a thing, right? In C++, there's no easy way to do that. We have to make functions for this. So we can make a function called getName and another function called setName, right? And now, if you talk to Connor, he's like, that's cancer. That's what he's going to say. That's terrible. Why the hell would I wrap my stuff up? I just want to directly access everything. He's right. If you want to directly access it. But what if, whenever you directly access something, you want something else to happen? What are you going to do? Set up an event? No. We never directly access stuff. We want to go through the window of another function, which allows us to do other things, other behavior when we're accessing or when we're setting. And it gives us control. Directly accessing something, you've given up your control. You have no control to do anything after that. You've just done it already, right? It's that fast. But going through a function, it's a whole function. You can do a bunch of stuff in there, right? You can test it. You can do some troubleshooting. For now, this is pretty good, and I want to test this out. I don't need the protected section. I just put that in there just as a thing. So now I can go down here, and let's change Tom. Instead of it being a person, let's make it a student. Let's do this. And we're not instantiating an object of class person, we're instantiating an object of type student. But now we have a problem because, guess what, we're missing a parameter, which is the student ID. And we're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll put an A in the beginning, just to make it so it's really like an alphanumeric, input. And one thing I can also do now is I can go, let's call the studies function, and we'll call Tom studies. How can I do this? How can I access both the says hello function as well as the studies function if I'm a student? I can access the public function that is says hello, yes?
It's because the says hello function is within the public.
It's in the public area, right? And remember that we have a relationship between student and person. We have an is-a relationship. The student is a person, which means it has all the qualities of a person, right? Plus more. And here's something I want to ask you. What do you think is fatter in programming, the parents or the children? This is a common little question I ask. Yes? The parents are not fatter. They're fatter in real life, okay? But in programming, parents are not fat. They're actually the leanest things you can have. Why? Because I'm specializing with the child classes, I'm adding behavior, I'm increasing my memory footprint because I'm adding more functions. Therefore, every child is fatter than the parent, no matter what. And that goes back to what Connor doesn't like. When you talk to Connor about inheritance and on object-oriented programming, he's like, that's cancer. OOP is terrible. I don't want to ever use that. I don't need that. I want to do functional programming because of the inheritance chain. I'm inheriting this, and from there I'm inheriting that, and now the child leaf class at the bottom is fat as hell. Like in Unity. Your game object in Unity inherits from mono behavior, which inherits from a bunch of other stuff. Okay? That's why he doesn't like that. But guess what? It's a fact of life that in Unreal Engine and in Unity and almost every other game engine I've ever seen, everyone uses inheritance and polymorphism and OOP. Now there are some game engines that use an ECS, an entity component system, that does not use inheritance. Okay, we don't have to use inheritance for everything. We can also use something called composition, if that is something of another day. Very good question. Okay. Any other questions around this? All right, we just made our child class. Normally this is the you to do section, and we did our you to do section together because you're here inside of our class. If you missed it and you're watching the video, that's fine, but I'm not going to share this part up on DevOps at all, right? This is for you to do. Put it up on DevOps, please. Git add, git commit, git push. Git add, git commit, git push, yes.
For the get and set, would those be put in their own void functions within the public?
It wouldn't be void. Get would be whatever the data type you're getting, and set would be void.
Set would be void,
Because you're not actually returning anything.
and a get is setting.
Correct. Set is access. The set is mutating something, is changing something, and get is accessing something, and I got to get data back, I need that data back. So, you're to do git add, git push, right? Git commit, git push. Git add, dot, git commit minus n, and the method would be added the student class, right? Git push. Pushes to DevOps. that this is working and talk about, what I want you to do is talk a little bit about what you understand with OOP. Right? Talk about object-oriented programming, the stuff we just talked about right now.
When you say OEP, you just mean DevOps.
Object-oriented programming. I want you to talk about it. I want you to talk about some of the things we just talked about here in class. All right? We talked about instantiation. We talked about constructor functions. We talked about inheritance. We talked about a bunch of stuff. Talk about what you know. There's no workarounds. I just want you to talk about it. Right? Discuss it in your video and show me that your app, your little program works. Okay? I can show you that my program works right now because if I run it, if I've done everything correctly, then we're going to see another little console that comes up, and it's going to show me this thing. Let's take a look. Here it is. Tom says hello. Tom is studying, right? And both functions triggered. One function, let's go back to this. One function says hello comes from the person class, right? And the studies class comes from the student class. If you actually hover over, it tells you that. This is in class person, this is in class student. Now, my friends, this very basic thing that we've done today, like I said, we're walking, right? We're actually crawling up slower code, right? When we hit Unreal Engine, that's when we start to teleport, okay? And there's a lot going on in Unreal Engine. I want you guys for homework to read the stuff that I have inside of my PowerPoint, and there's also some great links in here that I want you to look at, okay? So, here's your homework for next week. Take a look at this little simple OOP review, all right? This talked about everything that I talked about already. You can also use this as a reference when you're making your video. Talk about things like classes and objects, okay? Then, some core components of OOP, data hiding, right? Like we talked about, inheritance and polymorphism, and what they are, right? Do some reading. This is for your own good, because you know what, guys? Everything we do here on in is using C++ and OOP, right? Object-oriented programming. And different OOP characteristics and so on, right? And let's take a look at other things. The gameplay framework is also something I want you to read about. There's a link here, if you actually can take a look. Read about the gameplay framework, please. Right? It'll bring you to the latest version of the documentation for the gameplay framework and what this includes. Okay? Because we're going to be using it next week with Unreal Engine. Okay? That's important to do. As well, inside my PowerPoint, there's another thing that has to do with the Unreal Reflection System. The Unreal Reflection System is a way that we're going to use macros, that's what they are, to basically decorate our properties and classes so that Unreal understands what they are. Okay, that's what we're going to do. So that's what these things are. There's properties, functions, and classes, and other constructs. And we're going to use them, and we're going to use the reflection system to do that. Okay? There's a lot here. And learning Unreal Engine is one part of it, which we're going to do a little bit with Steve. So you guys didn't have Steve this week, right? So that's why I have to wait a little bit. I was going to do more Unreal Engine today too, but I was, one thing I will do with Unreal Engine before we go, and this is the last thing I want to talk about, is let's pull up your Unreal Engine installation on your machine in front of you, please. And what I'm going to do is this. I'm also going to say this. If you have a machine at home that is way faster than your laptop, or you're on a machine at school and you want to access your machine from home, you can remote in using Google Remote Desktop, okay? Which is what I do a lot of times. Here, let me show you. So I'm going to go to Google Remote Desktop. There it is. I've already set up Google Remote Desktop on my machine at home. I have two of them. I have a Mac Studio that I use for mobile development. If you're a mobile developer, you need a Mac. There is no way around it, okay? And I use my desktop when it comes to Unreal Engine. And I'll tell you what, my little laptop here, which is has a GTX 1080 and 32 gigabytes of RAM and an 8th generation Intel i9, is not powerful enough to run Unreal Engine. It's just not, okay? What you need now, if anything, is you need at least, here's Unreal Engine running at home. the thing that you need at the minimum, if I was going to buy a brand new machine today, is an RTX 4070 or higher, okay, 4000 series. I wouldn't get a 3000 series anymore. I know you're shaking your head. You're like, why, okay? And so this is the template that I created in the first class. It doesn't do much right now, but I want to talk about Unreal Engine and installing it. You will need to do this for the people that are going to be remote at some point. You need this to work because we're going to do Unreal Engine even on the remote weeks. So you need somewhere to run this thing. Now, if you have a brilliant machine at home and you want to do it from here with me on those remote weeks, remote in, set up Google Remote Desktop from home and then teleport into your home and control your stuff from home. It should be pretty good, like I'm doing right now, okay? And notice that I have 3 installations, 544, 554, 561. And there's also other times I installed 427, right? I highly recommend having 554. 561 is not required. You don't need this. And 544 is a good backup, but you don't need this. So far, I have 241 gigabytes of installation stuff just for Unreal Engine, right? This requires a second drive, okay? I have a D drive, that's about 4 terabytes, and I put all my Unreal Engine stuff in, okay? As you can see, I have a lot of projects right here, and I also have a ton of stuff in my library. Okay, these are all the stuff that I have in my library for Unreal Engine. Take a look. Okay, tons and tons and tons of projects. Where do I get all this stuff? From Fab. Fab takes the place of the Unreal Engine Marketplace. It's brand new. And if you look at Fab, when you sign in with your Unreal Engine credentials, you can go to Fab and go to free. So limited time free, featured content. And every month they have some featured content, projects that are free that you can grab from the Unreal Engine Marketplace, Fab. 100% recommend it. More and more stuff comes out every month. This next one is going to last, this one lasts until September 9th. And then there's going to be another free package that comes out. Right? Highly recommend. You can't go wrong. Some of these things are like $100 or more each, right? And you can use these things for assets, okay? So that is something that you want to do. Let's go back to library. So at the minimum, and I'm recording this for you guys so you'll see it on Saturday, but at the minimum, what I highly recommend is when you install your 554, there is an options area here. And what I want you to do is also install editor symbols for debugging. If you don't, when you do Unreal Engine with C++, then you'll be missing some functionality. I have those installed here on the machines in front of you. It was very painstaking work with IT to get it done. And they would not put an extra version of Unreal Engine in, no matter how much I was pressuring them. They're like, no, you only get one version. Which one do you want? And I didn't want the latest version because 561 updates regularly, right? It'll cannot keep on updating throughout the entire semester. And IT will not update our stuff ever in semester, right? So that's why we went with 554, okay? 554 is a good, respectable version of the engine. 561 is better. It's a little bit more efficient. Highly recommend use 554 for your project. Don't go with 561. It's still a lot of experimental stuff in there, and I don't want you guys to break anything. So that's the thing. So that's your 554 installation. I recommend doing this, okay? Questions around Unreal Engine. You're going to need Unreal Engine, if you don't have it already, next week. Be prepared. So if you're going to put it on your little laptop over there, have it ready for next week. We'll be using Unreal Engine, and you must install all the features that it's mentioned. If you don't, I don't know if you have the space for it here. Do you have space in your laptop?
Yeah, that's good.
Awesome. Then you'll be great. If not, you will not be able to do in-class exercise 2. Okay? So please make sure you get that. I will give you a starter for next week that you will open for Unreal Engine for your in-class exercise 2. Starter, right? So you will not start with this like person class. We're not going to do that. Okay, we're doing something completely different. So make sure you have all that ready to go. Questions before we go for the day? Yes,
For the ice one,
yes.
do you want us to like attach like into the repository anywhere?
Remember the two things I need?
Yeah.
I need a YouTube link and your DevOps link. Those two things. I need those two things. Yes.
For the DevOps, how do we like grab that?
You grab it from the very good question. So one of the questions is, how do I grab that DevOps link? Let me just get out of this, and let me just kill my desktop for a second and come back to here. Here's my repo. Here's this link right here. That's it. Right? Now, before you go, here's what I want you guys to do. I'm going to stop recording now, and I want you guys to come up and check to see if your DevOps is working for me, because if it's not, you get 0, right? And I don't want that to happen tomorrow. And you're going to try and reach out to me, and I'm going to be busy with another class and busy in the afternoon, and just going to, why waste the mark unless we have, so we're going to take some time. We still have got like about 12 minutes left. I'm sorry it's going to take time, but we need to do this. If we don't, you're going to have problems. So let's start with you. Come. I'm going to stop recording now, guys. Thank you. For those people who don't care or